Okay, I'll discuss that correct sentence about distance. Distance cannot be negative. So everyone knows that distance is a scalar, right? Distance only has a magnitude. So distance cannot be negative. It only has a magnitude. So A is correct. A is correct. Distance cannot be zero. Distance can be zero. If you remain at the same place, distance is zero, right? So B is wrong. C, distance traveled does not decrease with time. That is true. Unlike displacement, distance does not decrease. It can remain at a constant value or only it can increase. Let's say you go like this. You go like this. Distance is increasing, right? If you come back, still distance is increasing. But the displacement is decreasing. Displacement is the shortest distance. That is decreasing, but the displacement is adding up. That is just the distance, right? So the distance always increases or remains the same. Cannot decrease, but displacement can decrease with time. So C is correct. D, distance cannot be less than displacement. Distance cannot be less than displacement. Yeah, always distance is higher because distance always adds up. How much you go, it adds up to the value as the distance, right? So A, C and D. Yeah. The answer is fourth one, right? Answer is fourth one. Did anyone get the correct answer? And if you have a problem, an issue with this, send me a message. I think everyone got that, right? A is correct, right? A is correct. Okay, right. Okay, then we'll move on to the second question. I'll give you like 2 minutes to try that. What they ask is average speed. So I gave you the equation. You just have to divide total distance by total time. I'll give you like 2 minutes. Try that. Second question. Those who got the answer, send me a message. And if something is not clear, send me a message, right? Okay. 1/3 of a total displacement. So let's say S here, S here, S here. So these are the equal distances. All 1/3 of the total displacement. Total distance is 3s. Total distance is 3s. So what you need is, so 1/3 of the total displacement, right? So the first part is traveled at 10 meters per second. Second part 20 meters per second. Third part 60 meters per second. Right? Then what you need is average speed. So average speed is total distance divided by time. Total time. So what is the total distance? You can substitute as SSS 3s divided by total time. So for this one, how much is the time here? Within this range, the object moves at constant velocity, 10 meters per second. So you can say for this one, time, you apply S equals ut, right? So S divided by distance, velocity, that is the time here. For the second part, time should be S divided by this speed, 20. Third part, time should be S divided by 60. So that to get the total time, you just have to add all these times. So that is T1, T2 and T3. So 3s divided by s divided by 10 plus s divided by 20 plus s divided by 60. 3s, you can take s out of these three. So what do you get? 1 over 10 plus 1 over 20 plus 1 over 60. I'm explaining these simplifications as well, right? Because I know some of you have problems with them as well. So this s cancels off. Then what do you get? 1 divided by 1 over 10 plus 1 over 20 plus 1 over 60. When you get a calculation like this, what you have to do is multiply both denominator and numerator by the common denominator here. So 10, 20, 60, common denominator is 60, right? So multiply both by 60. So what you are doing is you are just multiplying by the same number. So you are multiplying that by 1. 60, you can do that. Okay, numerator 60, multiply the inside, 60 times 1 over 10, that is 6. 60 times 1 over 20, that is 3. 60, that is 1. So 60 divided by, this is 6, 3, 10. So the answer should be 6 meters per second. So that's the average velocity. If you have an issue, send me the problem, right? So the answer should be 6 meters per second. Is it given? What went wrong? Here there's 3, right? I missed the 3 here. There's a 3 here. I missed that. So there should be a 3. 3 times 6. So it is 18 meters per second. Understood, right? So the answer should be fourth one. Not the first one. Fourth one. Answer should be fourth one, right? Take it down. It is okay, you can thumbs up, right? Right. So this question is based on average velocity, and within each range we have constant velocity. So within this range it is not accelerating, we have the constant velocity. Then the whole motion is just to find average velocity. Okay, then try the third question as well. I'll give you a minute, try that and send me the answer. That also is constant velocity. Third question also is constant velocity. So you can use S equals ut. If you want, you can draw a sketch. Okay, then try the question. You need to have that skill to like read the question, then draw a sketch to that. Okay, then you don't have to look at the question again. Everything should be in the sketch. Okay, so both cars starts from the same place. Speed of A is 50 kilometers per hour. You don't have to convert 50 kilometers per hour, right? Because the answers are also in 50 kilometers per hour. We have 60 kilometers per hour. But the car B start after 1 hour. Car B start moving after 1 hour. So what they ask is time required for car B to pass A. So car A is already moving to this side, but the car B is waiting for 1 hour. Then when the car A is somewhere here, B starts to move. Then what happens? Car A is ahead of B, but since the speed of car B is higher, car B can catch up A somewhere here. So what they ask is time required. Let's say time required for car B to pass A. So what they ask is time required for B. So let's say that time is T. That is for T, right? What they ask is time required for car B to pass A. So what you have to find is simple T. The other thing is, you know that car A has been moving for 1 more hour, like. So the time it moved should be, if this is T, this should be T plus 1. So that's what you have to understand. Then the thing is, when this happens, distance traveled by A and distance traveled by B should be the same. So what is distance? Instead of this one, you can put UT. So what is U? 50 times T plus 1. UT, right? U T plus 1. Here the T is T plus 1. For SB, it is 60 times T. Okay. If you didn't get that, send me a message, right? Okay, then you can cancel off this 0 from both sides. Other thing is, when you are simplifying a equation, right? Get rid of everything you can, like, don't leave anything, right? When you can cancel this one, many students don't cancel that. They keep having that till the end, right? But once you write the equation, cancel everything that you can, right? Then it gets very easy. Okay, then here it is 60, here 5t plus 5, multiply by 5. Then take this 5t to the other side, so it becomes minus 5t. So 5 equals 60 minus 5t. 6 minus 5, that is t, 5. Answer should be hours, right? 5 hours. Did anyone get the answer? 5 hours. So car B takes 5 hours, right? Got it? Right. Okay. So those are like some of the questions. These 3 questions were based on average velocity and constant velocity. Okay. And if you have any problems, you can ask me those questions later. Right. Later as well, right? Right. After that, I'll move on to practice linear motion equations. So for these equations, there's an acceleration. Acceleration is not 0 for these questions, right? So the previous 3 acceleration was 0, but for these questions, acceleration is not 0 and acceleration is a constant. Acceleration must be constant, right? For changing accelerations, you cannot apply linear motion equations, right? Before going to the other part, some students might not know this. You should be able to convert these into meters per second if it is required. So how do we do the conversion? Kilometers per hour should be multiplied by 5 over 18. 5 over 18. If you need to convert meters per second into kilometers per hour, you have to multiply this by 18 over 5. This you should know. Okay, you have to remember that. Okay, take this down. Put a stomach and take this down. Kilometers per hour 5 over 18. That is going to be meters per second. You should be able to do this within a short time. Okay, then try fourth question. Try the fourth question. These are linear motion equations. I gave you 4 equations. So you just have to choose one of those equations. Just mention the details given in the question. It starts at rest. So initial velocity should be 0. Mention that. Acceleration 2 meters per square second. Achieve a velocity. Achieve a velocity means V. That is the final velocity, right? 36 kilometers per hour. So you must convert this into meters per second. What do? Multiply this by 5 over 18. 18 means 1, 2. So this is 2 times 5, 10 meters per second. So this is the final velocity. So what they ask is time and the distance. Then once you see these details, instantly you should be able to say what the equation that you are going to use, right? Okay. So this is the equation, V equals U plus AT. Final velocity is 10. Initial 0, acceleration 2 times t. So t is equal to 10 divided by 2. 5 seconds. Then they ask distance traveled and the time is given. So this is the equation that you should use. Initial velocity 0 plus half, acceleration 2, time is 5 squared. So it should be 25 meters. Have any issues? Tell me, right? So the answer should be fourth one. Yeah, the answer is fourth one. Correct. Okay. So the skill here is once you see the problem, you should be able to identify instantly which equation to be used, right? Okay. Then try next one, fifth question. If you have any issues, let me know, right, in the chat box. Okay. So airplane should have velocity 5 meters per second, meaning airplane initially is at rest, right? Initially at rest. You know it needs a runaway and it needs to move along a runaway in order to gain the speed. So the airplane could fly from here. It needs a speed, right? It cannot go up without a speed, right? So the final velocity, it gains a speed 50 meters per second. And the runaway required is 500 meters. So almost half a kilometer. 500 meters. So what they ask is acceleration required for this, right? So once you see this question, once you see which equation should you be using? Initial velocity, final velocity, and a distance. In this question, time is not involved. So you have to use an equation that doesn't have time, right? So the only equation which doesn't have time is this equation. Then you just substitute. So V is 50 squared, U is 0, plus 2, acceleration is what we need to find, times 500. So 50 squared is 25, two zeros, 25 hundreds. 2 times 500 is 1000, 1000 A. Okay. Divide both sides by 1000. Cancel these 3 zeros, then put a decimal here. 2.5 meters per square second. So that's the acceleration. So this is the acceleration required. So the answer should be third one. Yeah, answer is third one. Okay, then try 6 question. You have to draw a sketch first. If the question looks complicated, you can draw a sketch, right? Even if you get like a simplification or calculation problem, ask me, right, in the comment section. So object starts at rest. Acceleration is denoted by 2 arrows. Get used to draw sketches like this, right? And the acceleration is 1/5 meters per square second. It moves for 40 seconds. And then achieves a maximum velocity. After that, decelerates. So the deceleration can be marked like this. Acceleration to the opposite side is deceleration, right? So it is not given. I think we need to find that. And finally it stops. Finally it stops. The key point about this question, yeah. Oh yeah, the fourth question answer is 4. Yeah. Right. The thing about there's something you need to learn from this, right? From here to here, it is a one acceleration. Then from here to here, it is a different acceleration. So you cannot apply a one equation from beginning to the end at once. You cannot apply one equation, right? Because you have two different accelerations. If the acceleration is the same, you can apply from here to here. It doesn't matter. So what you have to do is you have to apply from here to here, then from here to here. So what they ask is this deceleration. Before finding that, you need to find Vmax. I'll say Vm. You can easily find that. So you apply an equation. Let's say this is A, B, and C. First, you apply the equation from A to B. So from A to B, at B, that is the final velocity is here. So that is Vm. Initial velocity 0 plus acceleration 105, time is 40. So this is 8 meters per second. This is Vm. Okay, we found that 8 meters per second. Right. Here the time is given as 24 seconds, right? For this deceleration, it takes 24 seconds. 24 seconds. Okay. Again, you just have to apply V equals U plus AT. But in this instant, we are applying that from B to C. B to C. Okay. For an essay question, you have to mention these for an essay question, but for an MCQ, you don't have to. You just have to get the answer. For essay question, you need to mention these, right? You don't have to write sentences, just you can write B-C like that, right? Okay, so for B, to C, here the final velocity 0, initial velocity 8. It is 8 now, right? At B. Plus AT. Time is 24. Then you can take this to this side, so it becomes minus 8 equals 24A. So A is equal to minus 8 divided by 24. 3 times 24, that is 3. Minus 1 over 3 meters per square second. So it is clear, since we get a negative value, it is clear this should be a deceleration. So deceleration is 1 over 3 meters per square second, right? So we have 3 answers with 1 over 3. In that case, we have to find this distance as well. This distance as well. What is the easier way to find the distance? Easiest equation to apply? BC distance, I think they ask BC distance. No, the total distance. They ask total distance. So you need to find this distance plus this distance. So to find S1, I think this equation is better. Because U is 0 plus half, acceleration is 105. T is 40 seconds. 40 times 40, I write it like this, 40 squared, right? So 120, 5 cancels, then this becomes 4. Follow the simplification methods I'm doing, right? 2, 1, 5 is 1, 20. So 4 times 40, that is 160. 160 meters. Got it? So that is S1. Then we need to find S2. How do we find that? I'll apply from B to C. V squared, U squared, I think we'll can get the answer like that. So I'm applying from B to C, right? So V squared. Here the final velocity is 0. Initial velocity is 8. 8 is squared. I'm putting a minus sign because it is deceleration, right? So 2 times acceleration, we found it as 1 over 3 s. Take this whole thing to the other side. 2s divided by 3 equals 64. Then divide both sides of the equation by 2. 32. So S2 is equal to 3 times 32, cross multiply. 6, 9. 96 meters. So the total distance should be 160 plus 96. 6, 15, 256 meters. Answer should be third one. Yeah, answer should be third one. And if you have any issues, send me a message, right? Then try 10th, sorry, not the 10th, 8 question. Right. So there's a car. Its speed from 30 to 50 decreases within 10 seconds. So from this one you can find acceleration. So the final velocity 15, initial velocity 30 plus a times 10. Take this to the other side. Minus 30 plus 15, that is minus 15, 10a. So a is minus 1.5. So that is the deceleration, right? So how long, so this is the deceleration. So it is keeping this deceleration till it stops. Yeah, after this one, right? Yeah. after 15 meters per second. Then you need to find this time. So this equation from A to B, then to C. I applied this equation from A to B, then I'm applying from B to C. What they ask is this time, after achieving 15 meters per second. Yeah. Apply the same equation again. So the final velocity here is 0 now at C. U is 15. Deceleration is the same. It is a negative time. So time is 15 divided by 1.5. 15 divided by 1.5. Some students have problems simplifying something like this. So you can multiply both numerator and denominator by 10. So this becomes 150, this becomes 15. So the answer should be 10 seconds. Yeah. Answer should be 10 seconds, right? So what they ask is time after achieving this 15 meters per second. Right? Okay, then try 12th question. 12th question. Draw a sketch first. You have to convert this into meters per second. 1. So 54 is 3/18, right? 3 times 5, 15 meters per second. You have to do the conversion. If you get the answer, send me. It is not a hard question, it is an easy question. So you have to solve the question once the train starts to applying brakes. So the train is applying brakes 0.5 meters per square second. Quickly send me the answer. Doesn't have an answer. Actually, the train is moving at 15 meters per second as it applies the brake. Then it applies the brake, then the velocity becomes 0. So which equation can we apply? This doesn't involve time, right? So which one should you apply? V squared? This doesn't involve time. Final velocity 0, initial velocity 15 is squared. I'll put a minus because deceleration. 0.5 is half, right? I'm putting a half here. Times s. 2 cancels off. Minus s comes to the other side, becomes plus s equals 15 squared. 225 meters. Second one, right? Okay. Okay, then try 16th question. 16th question. Try the 16th question and send me the answer. 16, right? Okay, so this question also has an important concept. Important concept, right? Within the fifth second, what does it mean? Fifth second? Not after fifth second, right? Within the fifth second. So meaning within a 1 second, but that is the fifth. So here the t equals 0. Fifth second means time between fourth second and fifth second. Fourth second and fifth second, right? If they say nth second, within the nth second, so then that is going to be nth second and n minus 1 second. Time between n minus 1 and n minus 1 and n, right? So that is the nth second. This is fifth second. If they say third second, then it's going to be t equals 2, t equals 3. Always one less, right? So that first second means 0 and 1. So they say within fifth second, so within this, it moves a distance 90 meters. What they ask is velocity at the end of the fifth second. End of the fifth second is this one. What they ask is this v. Right. So how can we find that? That's all they have given. They haven't given a value for simple acceleration as well. Haven't given a value. So I need to include this 90 meters. So what I'm going to do is, let's say from here to here the distance is s1. Then from here to here the distance is s2. Right? So s1 minus s2 is equal to what? 90 meters. S1 minus S2 is 90 meters. So I'm going to use that. Okay. So to find S1, I'm applying equation from here to here. Ut plus half at squared. U is 0. Half acceleration is a, we don't know that. From here to here, time is 5. So it is 5 squared, not 4, right? From here to here, time is 5. So we get 25 a over 2. That is S1. Then for S2, I'm applying from here to here. Initial velocity 0, half a. T squared is 4 squared. Time is 4 squared. So 16 divided by 2. 16a divided by 2. Then substitute it in this equation. You can find acceleration. Right. So 25 minus 16, that is 9. 9a divided by 2, 90. Divide both sides by 9, 10. Cross multiply, then you get 20. 2 times 10, 20 meters per square second. But that's not what they ask. What they ask is this v. You know the acceleration now. So if you know the acceleration, just apply equation from here to here. U plus at. Acceleration 20. Time is 5. 100 meters per second. Fourth answer. Did you understand that? So the answer is fourth one. If you have any doubts, send me. Right. Then I'll move on to the next theory part. I'll just give you a short note on that theory part, right? Write down the topic motion under gravity. Motion under gravity. Right. So this is motion under gravity, meaning So you're just basically what you're doing is you're just giving an velocity to an object, so the object goes up and it falls down, right? In this case, AR resistance is neglected. AR resistance is neglected. Okay. Then there are some parts that the time to move up is equal to time to move down. And when an object moves up, at every second, its speed is decreased by 10 meters per second. Its speed decreases by 10 meters per second as the object goes up. And when it falls down, its speed increases by 10 meters per second. Okay. Yeah. So let's say, so you give this a velocity u. Then it goes up, falls down. It falls down at the same velocity. And the gravitational acceleration is always downwards, and the value is approximately 10 meters per square second. So in MCQs, you need to you know this stuff, but you need to apply this stuff in the MCQs when you know this one. Meaning of this is, when it goes up, at every second, its speed decreases by 10 meters per second, and it falls down, its speed increases by 10 meters per second. So that point can be used when you are doing MCQs, right? You don't have to apply equations in that case. Let's say this is A and B. Right. So whenever you have a motion question, these are important. You need to define the origin. Define an origin. And you have to assign a positive direction. Positive direction means everything to this side. To assign direction, any vector to this direction is positive. If the vector to other side, then it is going to be negative. Earlier we didn't want that, because for the previous question we didn't want that, because all the objects are moving to one side, right? But here objects are moving from here to here, opposite directions. So you need to be careful about this. So all you have to know is, to positive direction, if a vector is positive direction, it is positive. If it is to opposite direction, it is negative. That's all you have to know. So if you assign this direction to be positive, then the acceleration, this value is negative when you apply in equations, right? Other thing is, you can apply equation from O to B at once. O to B. What's the reason? Because acceleration, as it goes up, acceleration is 10. As it falls down also, acceleration is 10 meters per square second. Direction also does not change. Direction also does not change, right? So from O to B, you can apply the equations at once. From O to A or from O to B, you can apply the equations. Okay, just take this down first. Take this down first, then send me a thumbs up if it is okay. Right. Then we need to find this time from O to A time. So to find that, I'll apply this equation from O to A. We know the at the top velocity is 0. U is just U plus Here acceleration is minus g. I'm applying equation upwards, right? I'm applying equation upwards. This is g, t, like that. Take this to the other side, gt equals u, then t equals u over g. So this is the time required to move from O to A. U over G, right? U over G. Okay, take it down. Okay, then we need to find time required from O to B. So we call this flying time as well, right? That is the total time that the object flies. So when you need to find this one, you normally have to apply this equation, ut plus half ad squared. Because when it goes up and comes back, displacement is zero. Displacement is zero. So I'm trying to make terms zero as much as possible, right? That's why I applied this equation. Initial velocity u t plus half. Here it is, since I'm applying this equation upwards, acceleration is downwards. So minus sign t squared. Then divide the whole equation by t. U minus half gt. Take this term to the other side, half gt equals u, then cross multiply. T equals 2u divided by g. So this t is actually twice the time here. Twice the time here. Right. The next thing is you need to find the maximum height. Maximum height. So the easiest way to find that is this equation. So at the maximum height, velocity is 0. Initial velocity u is squared plus 2. I'm applying the equation upwards, but the acceleration is downwards. So this is minus g. S is h. So minus 2gh. Take it to the other side. Equals u squared. So h is equal to u squared over 2g. You don't have to remember this, right? Just remember the methods. It's better to remember if you can remember. You don't have to remember these ones, right? It's better if you can remember, but those are not standard equations. So if you took it down, try 18th question, 18th, and send me the answer. Draw a sketch. Acceleration downwards always doesn't matter, 10 meters per square second. And the object is falling down, initial velocity is 0. What they ask is velocity here and the time it takes. What's the answer? That's an easy question. So first you need to find v squared u squared plus 2as. So you need to find v. So notice that I'm applying this downwards, right? Equation downwards means you have assigned the positive direction to be downwards. So anything to this direction is positive, anything to other direction is negative. That's why you put a positive value here as the acceleration. This is a plus 10, right? Not minus 10. This is a plus 10. For the previous ones, we put minus because we assigned the positive direction upwards. Okay, so 10. So this is then h. H is given 3.2. So 3.2 times 2 is 6.4. 6.4 times 10 is 64. V squared 64. So V is 8 meters per second. That's the velocity this hits the ground. 8 meters per second. Then they ask the speed. sorry, the time, right? Yeah, time. So just get an equation that has time. So we found the final velocity 8, initial velocity 0, acceleration is 10. We are applying the equation downwards, so 10 is positive here. Time. So 10t equals 8, t equals 0.8 seconds. Should be third one, yeah. Then try 19th question, next question, and send me the answer. 19th. Released means initial velocity 0. It travels for 3 seconds. So what they ask is after 3 seconds what's the velocity and the distance traveled. What should be the answer? V equals u plus 80. So I can find V. So u is 0 plus a is 10, right? It also is positive because downwards. Time is 3, so 30 meters per second. That is the velocity it achieved. Then they ask this S. Apply downwards, S equals ut plus half at squared. 0, half, 10. Time is 3, 3 squared. So 9 times 10, 90. 90 divided by 2, 45. 30 meters per second and 45 meters. So the answer is first one, right? Yeah, correct. First answer. Then try 25. 25. You can draw a sketch first. Actually, it is projected upwards at a height 60 meters. So it goes up and comes down like this. So what they ask is time required for this to reach the ground. So it goes from here, right? Not from here. From here. Goes up, comes down. So whenever you get a question like this, that a sign in a positive direction is very important, right? Usually we assign the positive direction to be the initial direction, right? Initial moving direction. So positive direction is to this side. I'm applying that. So anything to this direction is positive. If something is to the other direction, it is negative, right? So 10 downwards. I can apply equation from here to here for the whole motion at once. The reason is acceleration is always downwards. It is always downwards 10 meters per square second for the whole motion, right? So I can apply a single equation for the whole motion. I'll apply that upwards. See this. This is the origin. This is where the motion is started, right? This is the origin. It goes up, comes down. Now it is behind 60 meters. So I can substitute this as minus 60. Minus 60. U is 20. That is upwards, so positive. T plus half. Acceleration downwards, so minus 10. T squared. So minus. So This becomes 5, right? Minus 5t squared. Take 5t squared to the other side. Take this to this side. It becomes minus 20t minus 60 equals 0. Divide the whole equation by 5. T squared minus 4t minus 12 equals 0. So 12 is, what is 12? We can take it as 6 times 2. 6t plus 2t. T minus 6 plus 2, t minus 6 equals 0. Take t minus 6 out. T plus 2 equals 0. T minus 6 equals 0 or t plus 2 equals 0. Here t is minus 2, which is not possible. So t should be 6 seconds. Time should be a positive value, right? So the answer should be the fourth one. Answer should be the fourth one. So the only point here is this one, right? This negative value. Okay, then try 21st question. 21st. Initial velocity 0. Acceleration, take it as g because in the options it is g. Nth second means n minus 1 and n. So what they ask is distance is traveled within the nth second. This is the nth second, right? This distance. So what's the, earlier we did a similar question. Take from here to here, then take it from here to here, S2. So S1 minus S2 should be the answer. Let's say that is Sn. So for S1, apply ut plus half at. Initial velocity is 0. So half g from here to here, time is n squared. S2, half initial velocity 0 from here to here. Time is g n minus 1 squared. Then substitute it here. Half g n squared minus half g n minus 1 squared. Take half g out. N squared minus n minus 1 squared. You cannot write this as n squared minus 1 squared, right? There are some students who write like that. That is not correct, right? You have to expand this. So what happens? A plus b squared is a squared plus b squared plus 2ab. So this should be n squared minus 2 times n times 1, 2n, plus minus 1 squared, that is plus 1. So this n squared minus n squared cancels off. Multiply this with minus 1. So half g plus 2n minus 1. This is the answer. This is the distance it traveled within the nth second. Half g 2n minus 1. Answer is fourth one. Yeah, correct. Fourth answer. Put a star mark and take this down. Put a star mark. Write down. With me, write down direction of acceleration. Direction of acceleration equals direction of unbalanced force. Direction of acceleration equals direction of unbalanced force. So this looks obvious, right? When you have a force to one side, that is the direction of the, because we can think about the direction of unbalanced force. Unbalanced force means just a force, right? We can think about that, but it is a bit hard. In some cases, it is a bit hard to think about the direction of acceleration. So whenever you have acceleration, think the acceleration in terms of unbalanced force. So whenever you have acceleration, think that in terms of force. Don't think that in terms of velocity. Always think that in terms of force. So when the object goes up, only force acting on that object is mg, downwards, right? That's why acceleration here is downwards 10. Mg does not change. At here also acceleration is 10. Why? Some students think here the acceleration is 0 at the top. It is not, right? Velocity is 0, but acceleration is 10 downwards. That's why you always have to think that in terms of force, because these are related, right? Force and acceleration. So here 10. Here also mg is still downwards. So the acceleration also is still downwards. So always for the whole motion, acceleration is 10. It is downwards. Think all the time acceleration in terms of force, right? Just remember that. Then we'll discuss this one. Let's say this object is projected upwards like this and it comes down. Okay. So the origin is here. Motion is started at O. So I need you to tell me, I'm asking of you displacement, S, velocity and acceleration. The sign of each of them, sign of displacement, sign of velocity and sign of acceleration. Okay. So let's say the object moved here. What's the sign of displacement here? So the positive direction, I assign positive direction to be up, right? So the sign here is the shortest distance. That is positive. S is positive. Then what about velocity? It is moving upwards. So the velocity also is to positive direction. Then what about acceleration? Acceleration is downwards. So positive direction upwards. So the acceleration minus here. At here, right? That's why you need to think acceleration in terms of force. Force is still downwards. Okay, so at the top, displacement is plus, right? Shortest distance to this side, plus velocity 0. At the top, velocity 0. Acceleration is not 0, it is still minus. Why? Mg is downwards, so is the acceleration. Okay, so let's say here, displacement. So what's the shortest distance to this side? Displacement is plus. Velocity, it is moving downwards, right? So in that case, velocity is minus. Acceleration is minus. Why? Mg downwards, so the acceleration also downwards. Assigned positive direction is upwards at this point. Then here, displacement is the shortest distance measured from origin to here. Here, shortest distance. It is to this side now, right? So the displacement is minus. Displacement is minus. Velocity, it is moving to this side, so velocity is minus. Acceleration is also negative, because it's still mg is to other side from this positive direction. So this is going to be very useful when we are drawing graphs, right? So this looks obvious, but draw this one, quickly draw that. So this will come in handy, right? Like when you're doing problems. Okay, so at the today's lesson we discussed about average velocity, uniform velocity, then applying linear motion equations under a constant acceleration, right? Then there are remaining questions. You have to try those questions at home, and if you have any problem you can send me a message and resolve that, right? But you have to try these. Then there are essay questions as well. There are like 14 essay questions. So the next class will be on the coming Thursday, next Thursday, same time, 8 to 9:30 p.m. I'll be discussing about projectiles. For projectile motion as well, we have to deal with the same stuff, right? Projectile also, motion also is, we have to deal with the same stuff. So when we are doing projectiles, you need to have a great skill in handling these linear motion equations. If not, projectile motion is going to be hard, right? Or confusing. So you have to try these questions, all the questions, right? There are not many questions, okay? Remaining questions and these essay questions, you have to try those questions at the home, okay? Then if you have any problems, send me a message, I'll resolve that. Okay. And if you find, if like many students have a common question that is hard, I'll discuss that question on the next class, okay? So this is, we are following like a great plan, like then I'm going to apply F equals ma, then work and energy. So at the end, you will see the result there, right? What we have been doing. Okay. Okay, we'll see you on the next class, right? Okay, good night, everyone.